everyone, and welcome back to our trigonometry lessons. And in this lesson we are going to learn how to draw the cosine function. Now the basic terminology for the cosine function is similar to that of our sine function, so we will revisit that with an example later on. Now when we want to draw the cosine function, we basically have to know what each of the values stand for. Now that y can be given another name, for example fx. So if you see fx, it simply means the same as y. And then there is a in front of the cosine function. That a is our amplitude, where the amplitude is the distance from the lowest point to the highest point divided by 2. Okay, great. So then we have also plus q there, and the plus q tells us whether the cosine function moved up or did it move down. Now, a cosine function has two shapes. Well, it can be positive, so if the value in front of this cosine function is positive, it makes this kind of shape like a porridge bowl. Do you see that? So from the point where it starts, it slopes down, makes a turn, and goes up again. Okay, great. Then if the cosine function is negative, it starts at the bottom and then it goes up and around and down again, almost like a little medieval helmet. Yes? Okay, great. So basically these are our two shapes, and you have to remember them, at least what the shape kind of looks like, especially when we have a positive function and when we have a negative function. Now, the cosine function also has a period of 360 degrees. This means that it takes 360 degrees for an entire cycle to complete. So for this entire graph to complete, it takes 360 degrees. Now, the rest of these we will look at as we do the following example. Now here we are going to look at y equals the cosine of x. I could also have written fx or hx or bx equals the cosine of x. So if we want to draw this function, and I'll show you later how to draw it, I just have an already assembled function here, so I'll quickly show you what this looks like. And there we go. So that is the basic shape for a positive cosine function. Now, this cosine function is our normal function. It didn't move up or down. There's no plus or minus value here, right? So look very closely. What is the amplitude? The amplitude is this value here at the front. We cannot see a value there because there is a 1. So the amplitude is a 1, okay? And the normal cosine function always starts at the amplitude. So this amplitude is a 1, and look where the graph starts. It starts at 1, okay? So that's quite important to remember. If it was a -1, where will the graph start? It would start at -1. Great. Now let's use this graph to answer the following questions. Now what is the minimum value? That is the lowest point of the graph as read on the y-axis. So that's the lowest point. So we just go horizontally to the y-axis. There it is. So the minimum value is -1. Okay, great. Then what's the maximum value? That's the highest point of the graph as read on the y-axis. That's the highest, and that's the highest, and if we read it off on the y-axis, it's a 1. So I can write here it's a 1. Okay, brilliant. Now the amplitude, well, there's two ways to calculate it. It's the distance from the lowest point to the highest point divided by 2. What's the distance from the lowest point all the way up until we're in line with the highest point? That is 1 to 0 is 1 unit, and another unit is 2 units. Okay, so from -1 to 1 is 2 units. Then we divide it by 2, so the amplitude is a 1. Okay, and we can also get it in another way. It's also the value in front of the cosine function as expressed as a positive number. Always expressed as a positive. Don't forget that. So what is the value here in front of the cosine function? It's a 1, and therefore we can write the amplitude is a 1. Okay, and if it was -1, we will still write that the amplitude is a 1. We always express the amplitude as a positive value. Then what is the range? From which lowest y value to which highest y value does the graph go? Well, the lowest y value, it is -1, and it goes to the highest value, which is a 1. And how do we write that? We say y is an element of, and it includes the -1, and it goes up as high as the +1. Okay, great. Always the lowest point first, then the highest, right? Then the domain, from which lowest x value to which highest x value does the graph go? So how far left? Well, it goes as far as 0 on the left side, and we're looking at the x-axis here, and how far right does it go? Up to 360. So from 0 to 360, so basically here at the bottom, I can write here that x is an element of 0, and it goes all the way to 360 degrees, and that is the domain. Okay, brilliant. Now let's look a little bit more at this graph. What if we add values here? Let's say we have the cosine function of x, and then we have a plus 1. Okay, so that's what our function looks like. It means that this entire function will move one place up, and if we move it one place up, and that is what it will look like. Okay, got it? And now what if we move it back to its original position, and then I'm going to scratch out that plus 1, and I'm going to make it a minus 1. That means this entire function moves one place down. So if we move it one place down, that is what it will look like. Okay, got it? And let me quickly put this away. So it doesn't matter what that plus or minus is, that's just how many spaces that graph will move up or down. So if I put this away, let's see what effect the amplitude will have. So if I scratch this minus 1 out again, and I put a 2 in front of this cosine function. So now it is y equals 2 cosine x. So the amplitude is a 2, and it also means that the cosine function will start at 2. So let's have a look what it will look like in blue. So there it is. And that is what the function will look like. See how deep it goes now? If we compare it to our first graph, which had an amplitude of 1, see how much deeper the blue one goes? Okay, great. Now, the same thing happens for the blue one. If we plus 1, the entire graph will go one place up. If we minus 1, then this entire graph will move one place down. Okay, that is how easy it is, and we can simply draw a cosine function with the help of our calculator. The important thing is that you just remember the basic shapes, and that it always looks like that when you draw it through our coordinate points. Now I also quickly want to show you what happens if this value at the front of the cosine function is negative. So if there is a minus in front of this 2, please remember that our amplitude will still be a 2, because an amplitude is always expressed as a positive number, okay? But now, if you keep your eyes on this blue graph, this is going to be a different shape now, because we have a negative function, and a negative function has this upside down porridge bowl. So I always remember it. I said earlier it looks like a medieval helmet, but a nice way to remember it, as if this is your porridge bowl, and you turn it upside down, your porridge will fall out, which is a negative thing, right? So it's the upside down bowl. Now, if you keep your eyes on this blue graph, it will simply look like this. If we have a negative cosine function, and look where it starts now. It starts here all the way at the bottom at minus 2, which is that value at the front of the cosine function. So it will always start at that value if it is a normal function that didn't move up or down. So there's no plus or minus value here. Okay, got it? So now let's go and see how we will use our calculator to help us draw the cosine functions. Now we are going to draw a cosine function, and this should not be hard because your calculator gives you the plotting points and the coordinates. So here is our function, fx equals the cosine of x, and we have to remember the following things. Remember the cosine function's shape. Now why do I say that? Because the shape is different for a positive function and a negative function, right? Okay, the positive function is the porridge bowl, and the negative function is the upside down bowl or the medieval helmet. Now, make sure your y-axis and x-axis spacing are correct. Okay, and look, these spaces are correct. And then we can use steps of 30 degrees, 45 degrees, 60 degrees, 90 degrees. Now, why are these steps so important? Because on the x-axis, we usually want at least 4 spaces or 4 values. So if they only wanted us to draw this cosine function up to 180, I will not just write 90 and 180. I will change my steps to 45. So I have 45, 90, 135 and 180. Got it? Okay. And the smaller your steps, the more coordinate points you will have. So you can go as low as 15 as long as you work with multiples of 15 up to 60 and then 90, not 75. So we want to draw this function, and I'm going to use 90 because 4 steps for this function will be enough. Okay, so let me open up my calculator like this, and then I'll quickly show you how that's done. You press the mode button, then you press 3 to access the table. Okay, and then they open up fx, and we are simply going to type in the cosine of x. Now, what if this graph or this function said hx or bx or px? Well, you simply assume that fx means the same, because remember, your calculator is pre-programmed to have fx there. So even if this is hx, you just assume that it's the same, okay? Because they are, it simply means y, okay? Y equals cosine x. It's the same as fx equals the cosine x. Okay, so let's continue here on the calculator. So we press alpha and x and then equal. Then the gx, just skip that part because we don't want a second one. We start at 0 degrees, we end at 360, and I'll quickly show you again. We start at 0 degrees, we end at 360 degrees. Okay, that's the range for, or the domain for which we want to draw this function. Then our step, we just decided we're going to make our step 90. So I type in 90. And there we go, and equal, and there's our table. So I'm going to pause it right here, and then we have our coordinate points. So basically, if x is 0, then our cosine function or the y value is 1, okay, or the fx is 1. So 0 and 1. So let's go to the x-axis where x is 0, which is there. And then we have to move up or down to find the y value, which is at 1. There we go. So I'll make a blue dot right there. And there it is. Now we go to our second pair. 90 and 0. 90, and we're on the x-axis, so the y will be 0 right there. So I make another dot there. Okay, great. Now let's go and check the 180 degrees on our x-axis, which will have a y coordinate of -1. So there's 180. We go down to find -1, and we plot a dot in line with that. There's the coordinate point of 180 and -1. Then let's scroll down on our calculator, down, down, and down we go, and another one. There we go, and now we can look at the two other coordinate points, which is 270 and 0. So at 270 we have a y value of 0 right there, and then at 360 our y value is a 1. So 360 we go up to 1, which is right there, and I'll plot that dot in here as well. There it is. Okay, great. So our dots are plotted, and now I can put my calculator away. There it goes. Okay, brilliant. Now we have a positive cosine function. I'll just quickly show you again. This is a normal function. It didn't move up or down. So it will start at this value at the front, which is a 1. And that's where we will start. Okay. As soon as this is a plus a value or minus a value, it will not start at that amplitude here at the front. Okay. And that's important later when we have a graph and we want to find the equation. So don't forget what I'm pointing out to you now. It is quite important that a normal function always starts at the amplitude when it is a cosine function. For a sine function, if it's a normal sine function, it starts at the origin. Okay, now this is a positive cosine function, so it's gonna be the soup bowl or the porridge bowl. So look at how I draw the shape. It starts here at 1, it goes down through the 90, then it starts to turn. It goes through that point, which is our turning point, and it goes up, and then it makes the turn again, and that is our porridge bowl. And there we're done. Okay, brilliant. So again, What is the amplitude? It's a 1. How do we calculate the amplitude if we just have the graph? We go from -1 all the way to 1, which is a vertical space of 2 units, and 2 divided by 2 is a 1, so our amplitude is 1. Okay, got it? Minimum value -1, maximum value 1, and we know most of the stuff here. Okay, so great. Let's go and try some more examples and answer some questions. Now here are 2 more examples that we are going to try, so let's see how we will draw these. Okay, and I want you to draw both from 0 degrees to 360 degrees. So here's our first one, minus cosine x plus 1. So it's a negative cosine function, so it's going to be the upside down bowl, and we're going to move it 1 unit up. So let's see if we use our calculator what that will look like. And here we go. So follow, and we type in the mode button, then press 3 to access the table here, or the functions. Fx equals minus cosine alpha x, and close the bracket, and plus 1 equal. Okay, we don't want gx, so you just press equal. We start at 0 degrees on our x-axis. We go all the way to 360 degrees. It's a cosine function. Our step is 90 and equal. And that is our table. So let's go plot our values. When we have x, which is a 0, okay, our y value will also be 0. So 0, 0. That is on the origin. So let me put that dot in there. And there we go. Now we go to our second pair, 90 and 1. So at 90 degrees, our y value will be 1. So let's plot that in as well. There it is. Okay, great. Now, the next one, 180 and 2. This is 180. We go all the way up to 2. There it is. And we can plot the dot right there. And then we wait to scroll down on our calculator. Down, 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 and one more down. There we go. And now we know that at 270 it will be a 1. 270 it will be a 1 right there. And I'll put that dot in. And then at 360 our y is a 0, which is on the x-axis. There we go. Now look closely here. This is a -1. If there was no +1 here, we would have started at -1, but then we moved the entire graph up 1 place. That's why we're starting at the origin. Okay, so it helps to understand your graph, and then you can easily draw it as well. And remember, this is a negative cosine function, so it's going to be the upside down bowl, and we have to make sure that we draw that shape correctly and not like straight lines. Okay, so here we go from the origin, and we go up like this, and then we make the turn, and then we go down, down, and we go out like that. And just make sure you go and end up and go through the dots. And that is our shape. Okay, so great. That is the minus cosine function when we move it 1 place up. Now, let's put away this calculator and answer the following questions. What is the period of this graph? Well, the period for a cosine function is always 360 degrees. What is the minimum value? It goes as low as 0 on our y-axis, right? That's the lowest point, that's the lowest point, and it is a 0 on our y-axis. So the minimum is a 0. What is the maximum? Well, that's the highest point. It will be a 2. So I can write here 2. What is the amplitude? Well, our amplitude will be a 1, even though that value there is a -1. It's always expressed as a positive value, but let's calculate it as well. From the lowest point, which is 0, all the way up to the highest point, which is 2, it's 2 units. 2 divided by 2 is 1. Okay, so our amplitude is 1. What is the range? Well, it goes from 0 all the way up to 2, right? So now we just have to write it correctly. So y is an element of 0 all the way to 2, and close the bracket. And then what is the domain? The domain is how far left to how far right. On our x-axis, it's here at 0. It goes all the way to the right to 360. So look how I write it here at the bottom. We simply say x is an element of, it starts at 0 and it goes all the way to 360 degrees. And there we are done. Okay, brilliant. So now let's go and see what we will do to draw the following function. And we do all of these functions similar, so you can practice them as well with your calculator. So the first thing I do is I take my calculator, I will open it up like this, and then let's see what the values are. So I type in mode, I press 3 to access the table, then the cosine and alpha x. That alpha is important to activate that x there, -1. Press equal, we don't want gx, so you just press equal again. We start at 0 degrees, we go to 360 degrees, we use a step of 90 degrees, so there we go. Press equal, and that is our table. So again, we've got 0 and 0. So let me put that in, and I'll do that in blue as well. So 0 and 0 is right there. Then we have 90 and -1. So that's 90, -1 is down here. So let's put that dot in. There we go. Then our next value is 180 and -2. There's 180, -2 is down here. And there we go. And let's scroll down on our calculator. And down we go. And 2 more, another one, and there we go. So 270 degrees on our x-axis, we go down to -1 on our y value. So there we go, and let's plot in that dot as well, and there it is. And last one, 360 and 0. 360 and 0 is right there, and I can put in that dot, and now I'm basically done. So I can put away my calculator here. And now we simply have to go and connect these dots with the correct shape. So here we go. We have a positive cosine function, and a positive cosine function is the porridge bowl. So let's just connect these dots. So there we go. It goes down, then it makes the turn, and then it goes up through that dot again, and then it goes out like that, and there we go. Maybe not the prettiest one, but yeah, it's got the correct type of shape for a cosine function, and it also moved 1 unit down. We know that because look at the amplitude, it's a 1, and we were supposed to start at 1. Why didn't we? Because we moved the entire graph 1 place down. Got it? What is the period for a cosine graph? Well, that's quite easy. It's 360 degrees. The minimum for this function is a -2. So let me write that in, -2. The maximum is a 0. That's the highest point on the graph, which is at the 0 on our y-axis. The amplitude, we can just read it off, which is a 1. We can also calculate it, right? The range, that is y is an element from the lowest point to the highest point, and it goes from -2 to 1. We just have to make sure that we write it correctly. So it goes from -2, the lowest point, to our highest point, 0. And then the domain is x is an element. It goes from the most left part, which is here on the left, which is 0, to the part that's most on the right, which is 360. So again, x is an element of 0 degrees all the way to 360 degrees, and that is all there is to it. You can draw any of these functions with the use of your calculator. You just have to remember the correct shape and draw it through the dots, and that takes a bit of practice to know when you want to start turning out on your turning point and so on, but you can master it as long as you understand what is the basic shape, and when do we use the upside down one for a negative function, and when do we use the porridge bowl when it is a positive function. Okay, so keep practicing, work through this video, and see you next time. Bye. This is your host Richard T, and thank you for joining us. Please visit our website mathsa.co.za for free guided exam tutorials.